Hello, I'm Mr. Weiler, and today we're going to be doing more work with introductory trigonometry. So there's going to be a set of problems that I'm going to do that's going to be a follow-up to the last video we had. Alright, all of these problems are problems that you would do before you would start graphing sine and cosine, tangent, cotangent, etc. Before you'd start to investigate amplitude, frequency, midline, period, etc. Okay, so these are basic trig problems that really just use the content we talked about last time. Okay, but a variety of them. If you've seen them before in homework sets, that's not a great surprise. So let's jump into them. All right, problem number one. Which of the following angles would not have a reference angle equal to 30 degrees? Now remember, the reference angle, right, if I take any angle, like let's say I have an angle of, let me take one that doesn't have a reference angle of 30 degrees. Let's say I have an angle of 200 degrees, right? Remember, I always measure angles from due east. 200 would be more than 180, but less than 270. So a 200 degree angle, would be somewhere in here, but its reference angle, let me draw that in red, its reference angle would be right here. So my reference angle, when I have an angle of 200 degrees, would be 200 degrees minus 180 degrees, and that would be 20 degrees. All right, so 200 wouldn't have a reference angle of 30. So the question is, which one of these angles would not have a reference angle of 30? Well, let's draw them one at a time. 210. A 210 degree angle is also in the third quadrant, right? So 210 degrees. And if I wanted to figure out the reference angle, again drawn in red, I would do 210 minus 180, and that would be 30. So its reference angle would be 30. So that's not the answer I'm looking for. How about this angle, negative 330? Let me go back into blue. Right, 330, that's an angle that lies in the fourth quadrant, right? Because it's an angle that's greater than 270 but less than 360. So let me draw it that way. No, that's a negative angle. I'm so sorry about that. I need to go clockwise. Okay, and in fact, if I go clockwise, that will put me into the first quadrant, okay? Now keep in mind that negative 330 just tells you the direction you're going. So I'm going to leave it off right here. From an absolute value, that's 330 degrees. And again, the reference angle, here would be 360 minus 330, would again be 30 degrees. Let me get rid of all of this. Sorry about that mistake. All right, let me go back here. Let's try 120 degrees. Let's see what that's going to be. Let me go all the way down here. 120 degree angle, that's going to be in the second quadrant, right? Because that's going to be an angle that is bigger than 90 but less than 180, so 120 degree angle. Again, its reference angle, the angle from the terminal ray to the nearest x-axis, that would be 180 degrees minus 120 degrees, and that would have a reference angle of 60 degrees. So that's my actual answer, right? That's got a reference angle of 60 degrees. And I was looking for one that didn't have a reference angle of 30. Now let me just review something really basic about reference angles. The reason that we talk about reference angles is that reference angles, all angles that have the same reference angle, will have the same sine and cosine values. They just might be different by a plus and a minus, but the actual absolute value will be the same. Okay. Reference angles. I'm going to clear this out and then we're going to go on to the next problem, okay? Let's keep going. Problem 2. The distance from the center of a Ferris wheel to a person who is riding is 38 feet. Hey, let's draw that. Let's not even pause. We've got a Ferris wheel. Well, it kind of looks like a Ferris wheel. Dutchess County Fair coming up. Well, not for a while, but here's a person who's in a very precarious position on the Ferris wheel, but hey, whatever. And the distance the person is away from the center is 38 feet, right? That's this distance, the radius of that circle. What distance does the person travel if the Ferris wheel rotates through an angle of 4.25 radians? So as this thing is rotating, right, it travels through a distance. Let me draw the distance in red, right? The person travels through this distance around the circle. and they travel through a central angle, theta, 4.25 radians. Now I know that radians you're not used to them, but there's one formula that defines radians. The angle is equal to the arc length divided by the radius. So if I've got some kind of radius, r, and it travels through some arc length, s, right, then we've got theta. So this is the definition. Now what we're given in this case is we're given theta, it's 4.25 radians. We're looking for the arc length, that's the distance that we travel around a circle, and we know that the radius is 38 feet. So I can actually multiply both sides by 38 to figure out my arc length. 4.25 times 38 on my calculator gives me the arc length to be 161.5 feet. So, anytime you're working a problem, all right, that implies that you're going around part of a circle, right? So we got a Ferris wheel or the pendulum on a clock or something like that, right? Anytime, then there will always be three things in play: the arc length, the angle in radians, always in radians, not degrees, and the radius. You could be asked to solve for any one of these three things. In this problem, we were asked to solve for the arc length, and we were given the angle and the radius. But regardless, if you know you're dealing with this relationship, write it down, fill in the two parts you know, and solve for the part you don't. All right, I'm going to clear this out, so write down anything you need to. Ooh, let me circle the right answer, 161.5 feet. Okay, let's go on. Let's take a look at another problem. Problem 3. The terminal ray of an angle is drawn in standard position, passes through the point 0.2, negative 0.96, which lies on the unit circle. Oh man, is that important. Let's see, is that my highlighter? Yeah, that's my highlighter. The unit circle. Boy, is that important. And apparently you can't even see it now. Let me just erase that. All right, we'll just circle it in red. The unit circle. Which of the following represents the sine of the angle? Let's work through a bunch of different things here. First off, if we're on the unit circle, okay, that's a circle centered at the origin with a radius of 1. That wasn't too bad, which is a rarity for me. Okay, we're at the point 0.2, 0.96, negative 0.96. That might be some point down here, right? 0.28, negative 0.96. You might wonder why these things have to be so ugly. Keep in mind, if we're on the unit circle, right, every single value has to be between negative 1 and 1. Now, it talks about an angle being drawn in standard position. That means that its initial ray points that way, and its terminal ray points this way. So we're talking about that angle, and it wants to know the sine of the angle. Well, remember, on the unit circle, and this is key, on the unit circle, right, then the cosine of the angle is equal to the x-coordinate, and the sine of the angle is equal to the y-coordinate. All right, this is how we create the sine and cosine functions, how we extend them to angles that are bigger than 90 degrees, or that are bigger than or equal to 90 degrees. All right, so therefore this question is very simple. What's the sine of the angle? The y-coordinate. Now the key is, we know it's the y-coordinate because it's on the unit circle, a circle whose radius is 1. More generally speaking, the cosine of the angle will always be the x-coordinate divided by the radius, and the sine of the angle will always be the y-coordinate divided by the radius. But on the unit circle, r is equal to 1, and therefore these just become the x-coordinate, and the y-coordinate. All right, but a very, very easy question, as long as you know the basic idea. Cosine equals the x-coordinate on the unit circle, sine is equal to the y on the unit circle. All right, I'm going to clear this out, so write down whatever you need to. All right, here we go. Random phone ringing in the background. Let's do the next problem. All right, problem 4. For an angle drawn in standard position, there's that standard position again, It is known that its cosine is negative and its sine is positive. The terminal ray of this angle must terminate in which quadrant? All right, well, let's think about this for a second. Okay, remember our quadrants, 1, 2, 3, and 4, right? Remember that cosine of the angle is the x-coordinate, and the sine of the angle is the y-coordinate. All right, so we know that cosine of the angle is negative, but that must be the x-coordinate. Well, where's the x-coordinate negative? That's in quadrant 2 and quadrant 3. But we're told that the sine of the angle, well, that's positive, and that's the y-coordinate. Well, where's the y-coordinate positive? That's in quadrants 1 and quadrants 2. So the only place where both of those conditions are satisfied is quadrant 2. And again, what this problem really tests isn't any kind of mnemonic like all students take calculus or something like that, although that's helpful. But what it really is a test to see if you know that cosine is defined by the x-coordinate on the unit circle and sine is defined as the y-coordinate on the unit circle. Now you might say, yeah, but there's no circle there. Okay, now there is. All right, so take a look at this. It's a very common problem. Write down what you need to, and then we're going to move on. Okay, here we go. Problem number 5. When drawn in standard position, there it is again, standard position, an angle alpha has a terminal ray that lies in the second quadrant. That's very important. And whose sine is equal to 9 divided by 41. Find the cosine of alpha in rational form as a fraction. So I'm going to do this in 2 different ways, okay? And then you can choose which way you find easiest. All right, first things first, I'm going to use what's called the Pythagorean identity. All right, and the Pythagorean identity, which you've seen already, simply says that if I take the cosine of any angle, but I'll use alpha, and I square it, and I add the sine of any angle, and I square it, I'll always get 1. By the way, all this is the equation of the unit circle. X squared plus y squared equals 1. Remember, x is cosine, y is sine. So, since I know that the sine is 9 divided by 41, I can just put that in for sine. Now keep in mind, okay, because this can be very, very tricky. Keep in mind that's what the sine of the angle is. That's not what the angle is. I don't want to put that in for alpha. I want to put it in for sine alpha. So let's do some math here. We get cosine squared, right? 9 squared is 81. 41 squared, I bet I could probably pull that off, but let me just use my calculator. It's 1681, which is equal to 1. I'm going to subtract 81, 1681 from both sides. I don't know why I just wrote it like that. I apologize if it's confusing. 1 minus 81, 81 divided by 1681 is 1600 divided by 1681. Whoops, oh, that was cosine squared, so now I take the square root of both sides. Watch out. So cosine of alpha is going to be 40 divided by 41, but with a plus minus. Now this is so critical, I'm going to circle it in red. All right? The question is, which one is it? Is it the positive 40 divided by 41, or is it the negative 40 divided by 41? That's where this comes in, the second quadrant, right? In the second quadrant, quadrant 2, cosine is going to be negative because it's the x-coordinate, right? It's the x-coordinate there. So that means our answer is going to be negative 40 divided by 41. All right, that's using the Pythagorean identity. Now, let's do what's going to appear to be a little bit different, but really is the same. Now I'm going to use the Pythagorean theorem. Now what I'm going to do is I'm going to draw a little right triangle. Okay? I'm going to just label this angle alpha. You could also label that one, but let's make it easy on ourselves. Now what do I know? I know the sine of alpha, right? I know sine of alpha is 9 divided by 41. But I also know from right triangle trigonometry that the sine is the opposite divided by the hypotenuse. So that would be 9, and this would be 41. I'm looking for cosine of alpha, which will have to be adjacent divided by hypotenuse. Well, I don't know the adjacent side, right? But I could find it. I can find it using the Pythagorean theorem. So what I'll do is I'll call this A, and I'll just do a squared plus 9 squared is 41 squared. A squared plus 81 is 1681. A squared is 1600. And A, believe it or not, is plus or minus 40. Right? Really, it is plus or minus 40. Now you might say, hey, this is a right triangle, man. It's just got to be plus 40. Well, here's the thing. Certainly now the cosine of alpha, well, its absolute value, would have to be 40 divided by 41. But you've got to, again, figure out the plus minus issue on your own, and that still goes back to that second quadrant thing. And that's what's tricky. You know, the second quadrant means that the cosine must be negative, and in this case, 40 divided by 41. So we use the right triangle. We use the right triangle. Boy, is there a lot of writing on this page. My head must be that big right now. We use the right triangle simply to figure out the absolute value of the cosine, but then we use the quadrant to help us figure out whether it's positive or negative. Okay? Very important problem. They have it a lot on the Regents exam, so it's a good one to be able to do whether you use the Pythagorean identity or the Pythagorean theorem with a little right triangle trig. Either way, you'll get the right answer. All right, I'm going to clear out all this text. Here we go. Let's do problem 6. Ooh, if f of x equals 2x and g of x equals cosine x, then g of f of pi over 2 equals what? All right, well, forget about trig just for a moment. We'll get to trig. This is what's called a composition problem. It's the composition of two functions. So what I first have to do is I first have to figure out what f of pi over 2 is. Well, let's stick pi over 2 into the function 2 times x. Right, so I'm just plugging this in for x. Now, of course, that means f of pi over 2 is just pi. But now I need to plug that into my function for g. Well, g of pi is going to be the cosine of pi. Now, I'll be honest, you can use your calculator on this, and if you're really confused, you should use your calculator on this. If you're going to use your calculator, make sure that you use it in radians, not degrees, or it will give you an answer that isn't even one of the 4 choices. But let me really quickly review using the unit circle. Now, we're in radians now, and I get that that's a little bit tricky, and that is just a horrible looking circle. But keep in mind, this is how the radians play out. That's 0. At the top, it's pi over 2. At the left, it's pi. At the bottom, it's 3 pi over 2, and then back to here, it's 2 pi. Okay? If I want to know what cosine of pi is, I'm looking for the x-coordinate when the angle is pi. Well, because we're on the unit circle, that must be the point -1, 0. So the cosine of pi is -1. And again, if you're in radian mode and you ask your calculator what's the cosine of pi, it's going to tell you -1. But it's important that you're able to deal with radian angles on the unit circle, especially as you move into the graphing of the trig functions. All right, I'm going to clear all this out. Let's take a look at number 7. All right, which of the following could not be the value of sine theta? That seems like a weird question. Which of the following couldn't be the value of sine theta? Well, what do we really know about the sine function? What we know is that on the unit circle, for any angle, let me just draw like an obtuse angle, that we know that this point is going to be cosine of theta, comma, sine of theta. So the sine function is the y value. But look, or the y veil apparently. Let's try to spell that right. The y value, right? But look, the y value will always have to be between 1 and -1, right? So that's true for both sine and cosine. The sine value must be between -1 and 1, and so does the cosine value. These are what are called bounded functions. They're always between -1 and 1. So really, the only values that could not be a value of sine are values that are bigger than 1 or less than -1. Well, let's take a look. -11/13. Don't worry about the negative, just look at the 11 and the 13. 11/13. That's less than 1. This one's a little bit trickier. You could do it on your calculator, but keep in mind that the square root of 25 divided by 5 would be equal to 1. So this is also okay, all right? Absolute value, that's less than 1. 1/2, we're good there, so it's got to be this one. And in fact, if you actually worked this out on your calculator, let me do that really quick. The square root of 34 divided by 5. Well, the square root of 34 divided by 5 would be about 1.166. Well, that's bigger than 1. That's up here, right? That can't be on the unit circle. So there's our winner, right? Again, what this really tests is, do you understand where sine and cosine come from? Do you understand that on the unit circle, the sine and the cosine must just be those x and the y coordinates? All right, I'm going to be clearing this out. And let's keep going. Ooh, which of the following is closest to the value of secant of 52? Now, we've got sine, we've got cosine, and then we've got 4 additional trig functions. We've got tangent, and that's the sine of the angle divided by the cosine of the angle. Then there's cotangent, which is the cosine of the angle divided by the sine of the angle. And then we've got the secant, which is going to be 1 divided by the cosine of the angle. And we've got the cosecant, which is 1 divided by the sine of the angle. Now, one of the great ironies of these really kind of expensive and pretty powerful graphing calculators you have is that the only 3 trig functions that they have on them are sine, cosine, and tangent. They don't have secant, they don't have cosecant, and they don't have cotangent. So even though this problem seems like it's pure calculator, it does require some knowledge, which is the fact that secant of 52 degrees is 1 divided by the cosine of 52 degrees. Now, once you put that into your calculator, keeping in mind that you must be in degree mode, and you might be in radian mode right now because of that composition problem we just did, but once you're in degree mode, you just type this in. Let me do that. 1 divided by the cosine of 52, and we get 1.62426, etc. So it looks like that's closest. And again, this may seem trivial. You know, it may seem like, well, I'm just pushing some buttons on my calculator, and you are. But what it's really testing is, do you know that secant of an angle is 1 divided by the cosine of the same angle? You have to know that to do this problem. Your calculators don't have a secant button on them. All right, I'm going to clear this out. Here we go. All right, number 9. For which of the following values of alpha is cotangent alpha undefined? Well, let's write out what cotangent is. The cotangent of any angle will always be the cosine of the angle divided by the sine of the angle. Now, generally speaking, division is happy as long as you don't divide by 0. Can't be 0. Now, when I'm saying that this can't be 0, I don't mean that alpha can't be 0. It can't, but let's not worry about that right now. I'm saying that the sine of alpha can't be 0. Otherwise, it'll be undefined. So Let's think about where the sine of alpha is 0. Again, let's go back to that unit circle. Right? These look like they're in degrees, so let me put down 0, 90, 180. So I'm not labeling it with radians right now. I'm labeling it with degrees. Back to 360, etc. Right, we could keep going around. We could also go around clockwise. So I'm looking for where any locations where the sine of alpha is 0. Okay? But remember, the sine is equal to the y coordinate. Well, where's the y coordinate equal to 0? It's definitely going to be equal to 0 here, and definitely equal to 0 here. So the cotangent will be undefined at 180. Now again, it could just be that you say, well, no problem, man, I'll just type in cotangent of all these angles and see which one of them gives me an error. Again, the problem is cotangent's not on your calculator, right? So that could be a real problem. Anyway, it's a good review of the unit circle and the definition of cotangent. All right, I'm going to clear this out in a second, so write down anything you need to. All right, here we go. Okay, for an angle alpha, it's known that the tangent of alpha is less than 0 and the sine of alpha is less than 0. If drawn in standard position, the terminal ray of alpha would lie in which quadrant? Okay, so we saw a problem like this before, but it had cosine and sine. Now it has tangent and sine. Well, the sine's going to be pretty easy. Let's think about tangent again. Tangent of alpha is the sine of alpha divided by the cosine of alpha. Now in quadrant 1, actually let me draw the picture again. 2, 3, 4. I'm going to do a little easy thing. In quadrant 1, sine is positive and cosine is positive. Both x and y are positive. In quadrant 2, sine is positive because y is positive, but cosine is negative because x is negative. In quadrant 3, the sine will be negative and the cosine will be negative because both are negative. And in quadrant 4, the sine will be negative and the cosine will be positive. But see, now we can also figure out tangent, because tangent is sine divided by cosine. A positive divided by a positive is a positive. In quadrant 2, tangent will be negative, because a positive divided by a negative is a negative. In quadrant 3, tangent will be positive, because a negative divided by a negative is a positive. And in quadrant 4, tangent will be negative, because a negative divided by a positive is a negative. Whew. So what do we know? Let's just zone in here a little bit. We know that the tangent is negative, which means we must be either in quadrant 2 or quadrant 4. So from this, we know we're in quadrant 2 or quadrant 4. But the sine is also negative, so that's in quadrant 3 and quadrant 4, which means our winner must be quadrant 4. Right, there it is. Sine is negative and tangent is negative. All right, I'm going to clear this out. You ready? All right. So, what we did today was we took a lot of information about the unit circle, the fact that the cosine of the angle drawn in standard position is the x-coordinate, the sine of the angle drawn in standard position is the y-coordinate, and we used those to answer a whole variety of different questions that you've probably already seen come up in your class. All right? Hopefully this strengthened your ability to understand why those problems worked out the way they did, and hopefully also laid a firm foundation for graphing the sine and the cosine values that the sine and the cosine functions, that you're going to start seeing probably this week. All right. Well, for now, my name is Mr. Weiler. This has been more introductory trig problems from Algebra 2 and trigonometry. I'll see you soon. Take care. Study hard.